Hey guys, welcome. This is our stats study guide, and let's go over our questions and some answers. Here we go. So 3 ways data can be collected. Now there's more than 3, but these were kind of the 3 main that we talked about. Was doing a random sample, so going somewhere and sampling, a survey where you might pick out who you're going to survey, and observation. You can actually collect data by just observing things without having to perform a sample or survey. 3 ways data can be interpreted. Now we did a lot of interpreting. And some of the things that we used to interpret were the mean, the median, and the standard deviation were 3 of the most popular ones that we used to identify and talk about as far as what is our ways that we can interpret how data is. And 3 ways we can display data. Now we had more than these as well, but box and whisker plot was a big one where we had our 5 different number summary. Dot plot and histogram were a couple other ones. All right. Construct a dot plot for the given data. So I'm going to actually go ahead and do this off screen. Okay, there we go. Got our dot plot on there. And I numbered from 30 to 60 because I saw the lowest was around 32, the highest was 60. How many workers are 59 or older? So we can count 1, 2, 3, 4, 5, 6. What percent of employees are 50 are older than 50? So there's 20 total employers. So we take that total number, and older than 50 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we can go ahead and calculate that percent using our calculator. And we are going to get about 55%. What percent of employers are younger than 40? So we're going to go 1, 2, 3 out of 20. And we are going to end up with about 15%. All employers younger than 58 are called associates. How many associates are there? So basically we're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 20. And so we're going to go ahead and select, oh, wait, more than that. 9, 10, 11, 12, 13. Sorry, my bad. 58. I did not read that carefully. So that's going to be approximately 65%. So majority of them are under that age. All right, moving on. Explain what majority means. Majority actually means, a lot of times, sometimes people say 51% or higher. I think a better way would be over 50%. Okay, because you could have technically 50.9%. So over 50% would be considered majority. Okay? As the following questions using the histogram given below. How many people are registered? So this is the waiting time at registration. So all these people are registered. So we got 5 in this list, 4 here. That's going to be 9. Right here is 2, and that's 4. So we can just add all those together. And that's going to be, I think, 24. Yep, 24. What waiting time was the most common and least common? So 61 to 90 was the most common, and the least common was 91 to 120 minutes. Okay. At what range did 5 people have to wait? That would be from 0 to 30 minutes. And if wait time of more than 60 minutes, if a wait time of more than 60 minutes is only if you had a problem while registering, how many people had a problem while registering? So it was 60 or more than 60 minutes, so that would include anyone in this column had a problem. So 9 plus 2 plus 4, and that's going to give us 15 people had a problem while registering. What are the advantages of a histogram? Okay. Easily see data. That's a plus. Okay, what are the disadvantages? Not specific. Okay, so we don't have specific times. So we can easily see data and make overall observations, but disadvantages, can't really see the data that well. I don't know exactly how many people were in the 90 range versus the 61 range. All right, find mean, median, mode of the quiz. That's myself. All right, mean, we're going to add them up, so we're going to find the sum. So we're going to add all these up. 70 plus 13 plus 71 plus 77 plus 82 plus 77. and we're going to get 390. Then I divide by the total number 1, 2, 3, 4, 5, 6 items. So we divide by 6, and we're going to get our mean of 65. The mode, most common. Mode, the most common. So we see 77 twice. So our mode is 77. Median, we got to order this. 13, then we have 70, 71, 77, 77, and 82. And just count in. What's the middle term? Okay, it's right in between these two. So we're going to do 71 plus 77 divided by 2. So that's 148 divided by 2. And we get 74. Okay? What is the range of the data? So you're going to take the max minus the min. So that's going to be 82 minus 13. And we're going to get 69 as our range. Are there any outliers? I would say 13 is pretty far away from everybody else. So I'd say yes. Yes, probably 13 is an outlier. Okay. Given the data below, find the following questions. Okay. Now notice that this is already written in order for us, which really helps us. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. So we need to go ahead and identify my minimum, which is easy, 41. My maximum, 90. And let's go after our median first. So we're going to count in 1, 2, 3, 4, 5. So right in between these two is my median. So to find my median, I'm going to do 66 plus 70 divided by 2. And we're going to get 68 is the median. Then what I'm going to go ahead and do is I need to find my lower quartile and my upper quartile. So I have, this is the upper part, and I'm going to find the median there. 1, 2. Notice again I have to find the average of that for quartile 1. So that's 74, whoops, plus 81 divided by 2. And that's going to give me 77.5. Oh, wait, that was quartile. Sorry, I did that in the wrong spot. This is the upper quartile. I apologize. This is quartile 3. This will be quartile 1 then. I apologize. My mistake. So this is the upper quartile. We'll call that upper quartile in green. Versus our lower quartile is all down here. Now I'm including the 66 because it's technically not part of the median. And so we're going to count in. And we get these two numbers here, and that will find us quartile 1, which is the lower quartile. And that's going to be 47 plus 54 divided by 2. And that will give us 50.5. Okay? Create a box and whisker plot using our 5 key points. Well, 41 to 90 is how we're going to do it. I'm going to count by 5s, I think. So we'll go 40. I'm going to skip a box maybe every. No, I'll go, 45, 50, 55. Actually, that's going to be way too small. Let's retry that. I'm going to skip a box. 45, 50, 55. I'm going to move back closer towards it. 60, 65, 70, 75, 80, 85, and 90. Okay, so maximum is going to be at 90. Minimum is at 41. Our median is at 68, so that's going to be right about there. Our quartile 1 is at 50.5, that's right about there. And our upper quartile is 77.5, right about there. So we're going to put that box around the median and go out just like that. Okay, and then what an awful, awful looking picture, but heck, it does tell the story. All right, we are almost there. When I say almost there, I mean I think we're halfway. All right, use the box and whisker plot to examine the scores students receive. So what's the range of the data? Again, it's going to be maximum minus the minimum. So we're going to get, I think that's 95 minus, it looks like 20. Okay, so 95 minus 20 is going to give us a 75 range. That's a big range. What's the median? Right there in the middle. So median is that line in the box. That's going to be 40. Upper quartile value is right here. So that's going to be, I think, 75. Okay, I'm running out of colors here. Lower quartile. It's going to be this guy right here. Lower quartile looks like it's at 25. Min, 20. Max, 95. And we already showed that when we did our range. What percent of the students scored 25 or higher? Again, each one of these guys represents 25% of the data. Okay, so 25 or higher would be right here, so that's going to be 75%. What students score between a 40 and a 75? That would be right in here, so that's 25%. And it says, if the Boston Whisker plot represents 80 students, how many students scored between 20 and 75? Well, if we look up here, 20 and 75 is going to be 50% of the data. So if I take 80 students and I multiply it between, 20, that's going to be 75% of the data. I'm going to multiply it by 0.75. Okay, sorry about that. Yeah, from 20 all the way down here, all the way up to 75, that's going to be 25 plus 25 plus 25, that's 75% of the data. So we're going to multiply 0.75, which is the same as doing percent. So 60 students scored within that range. Okay, meaning 20 students scored above that. So we should write that 60 students. I apologize. Okay, let's flip it. Use the quiz scores to answer the following questions. We have 8, 9, 8, 7, 3, 7. What's the mean of the data? So we just need to sum it. 8 plus 9 plus 8 plus 7 plus 3 plus 7. That's going to be a sum of 42. 1, 2, 3, 4, 5, 6 data points. So we divide by 6. We get our mean value of 7. So data item, we write that in, 9, 8, 7, 3, 7. The difference between the mean and this, we're going to subtract. That's going to be 1. That's 9 and 7. That's going to be 2. That one we've already seen. 7 minus 7 is 0. This is going to be 3 minus 7 is a negative 4. And here we're going to get 7 minus 7, which is 0. Then we're going to square it. Okay, and when we square, we get 1, 4, 1, 0, 16, and 0. Add them all up. The sum is going to be, that's 22. So the variance here is actually then divided by the number of items we had. So we did 20, so take 22 divided by 6. So we're going to get the square root, or sorry, not the square root, just 3.6 repeating, and then we're going to square root that. So the square root of 3.6 is going to give us approximately 1.91 is our standard deviation. Okay, so that's a nice little problem there. Is there any additional, if there was an additional quiz score of 8 placed in the data, what measure of central tendency, mean, median, mode, and range would change, and which would stay the same? Okay, well, first of all, mode would change, right? Mode would become 8 for sure, because we'd have 3 8 values. Range would not, because 8 doesn't affect the min or maximum value. Okay. The mean, well, since the mean was 7, then it's going to change it. So the mean will increase, because it was 7, so if you're adding a value bigger, then it's going to increase median. Okay, well, we didn't actually calculate the median before. Here's our data set. If I were to put this in order, I'd have 3, 7, 7, 7, 8, 8, 9. So my median would be about 7.5. If I added another 8 in, though, then it would become 8. So it would change as well. Ever so slightly, not much. Okay? So everything's changing. The only one that doesn't change in this case would be the range. And it is a by basis on this. Explain what the standard deviation tells us about the data set. 1.91 is pretty big difference, and I think that's probably because of our outlier. The standard deviation is big, meaning our data set is spread out. But that might be because of our outlier of 3. Okay, if we took that out, we might actually have a smaller standard deviation. 1.91 would be really small standard deviation if all of our values were in the hundreds or thousands. But since these numbers are very small, 8, 9, 7, and 3, 1.9 is actually pretty big. So it says this data is kind of spread out, which isn't great for us. So let's move on. Last page. Below is a two-way frequency table, which shows the data collected on the preference of 50 students and the foreign language they prefer, or that they register for. Answer the following questions using two-way. How many men are taking French? So we look at French men, and there are 12. How many men are taking a foreign language? Altogether, there are 30 foreign language students. What is a joint? Now remember joint, relative frequency. We're going to take the total number, 50, divided by the joint number, them together. Men taking French. So German. So it's the joint 3. 3 out of 50 is our percent, and so we have about 0.06, or we would call that 6% are taking German, men who are taking German. What is the marginal frequency of men who took the survey? We're still doing this out of 50, but now we look at the marginal value. I think I dropped all my highlighters. So we look at the marginal value, which is in the margins. So if you recall, the margins are all these values here. So the men who took the survey was 30. And we're going to divide that, and we are going to get 0.6, or 60% again. We move the decimal over twice to find that. First time look at this table concludes that it's more likely that a man will take Spanish than a woman will take French. Is this accurate? Make sure you show work for credit. Okay. Man will take Spanish. Okay. Okay, well, Spanish is going to be a man who takes Spanish is 15 out of the total 50. Okay. So a man will take Spanish right here. Versus a woman will take French. That's going to be 2. Out of 50. Okay. And right there, this would be completely accurate. Now, if it worded this differently, if it said, a person looking at the table conclude that it's more likely if you're a man that you'll take Spanish than if you're a woman you'll take French, that'd be a different story. Okay? So, again, this would be true, yes, but if you reworded this and say, a man given you take Spanish, then we would do 15 out of 30. Okay. If you're a man, that's the 30. And which ones took Spanish? 15 out of 30. And 2 out of 20, which actually still get the same answer. Okay. Let's take a look at number 12. Construct a scatter plot of this bivariate data on the grid below. How would you characterize the relationship, positive or negative? It has everything here. So 1, 2, 2, 3.5, 3, 5, 4.5 comma 8, 5 comma 7, 6 comma 10, and 7, 10.5. Okay. Negative or positive? Are you kidding me? Positive. It's going up as it goes from left to right. Draw a line of best fit. Okay, this is where you would like to go ahead and use a straight edge if possible. You want to try and see if you can go through as many points as possible. Just like that. So it might be, what is the slope of the line of best fit? It looks like I'm going through this point and this point. So slope, I can actually just count. 1, 2, 3, up 3. Over 1, 2. So a run of 2. So 3 over 2. Positive or negative? Positive. Okay. And that is it. Alright guys, I will see you later. Bye-bye. Bye-bye.